Well, the pressure to develop the breeder came in the Nixon administration in the first energy crisis, where we had basically a cutoff of our oil from OPEC. And so the desire to have an energy independence with unlimited supply of nuclear energy was the dream that everybody had at that time. So the fuel then from commercial light water reactors could then be used in a breeder to create more fuel than it used up. So that was the dream, if you wish, and that was the impetus that caused the federal government to support this national effort in developing the breeder reactor.
We're standing in front of the best reactor test facility that ever was built in the entire world. The international community had a vision, it was shared by DOE, to create a reactor generation that created more fuel than it burnt. And that was called the breeder reactor. And it's a great vision. It was about 40 years ahead of its time, but it's still going to have a role in our society in the future.
Sam Volpentest at Glenn Lee, who owned and published the paper at that time, Sam was a big advocate for the Tri-City community, and anyway, they were able, through Senator Jackson, to get FFTF designated when the FFTF was authorized by the Congress in early 70s as the location for the test reactor, which was a part of the breeder program at that time.
In terms of physically what it was a 400 megawatt liquid metal reactor.
In a nuclear reaction, the neutrons are born fast. And in a normal thermal reactor, they're surrounded by water for cooling and moderation. It slows them down. But to breed, you need fast. And that's why the Fast Flux Test Facility has liquid sodium to cool it. And that is why it's called fast flux. Those are fast neutrons.
And we had the highest fluence, the highest concentration of neutron flux with the hardest spectrum, i.e. the highest energy of neutron flux in the US.
And that's what they wanted. You know, they would be all set up so that, okay, at 100% power, you have this neutron level in this part of the core for this experiment. And that was the product.
This was an international asset. We had people from all over the world using this facility for the breeder development. And the operation was actually spectacular. This was considered the best operating facility in the DOE complex, and that wasn't good enough for us. So we decided, hey, let's benchmark ourselves against the commercial sector. So we brought in the commercial regulatory agencies and said, test us. And they came back and said, we are in the top quartile of all the reactors in the entire country. That includes the material, all the commercial reactors.
And at the time, they said that the technical difficulties for building a breeder reactor, a faster test reactor, were more difficult than putting Apollo on the moon, putting a man on the moon, Apollo 1.
We proved a lot of things that could be used in the future possibly. We did testing with metals and got the lowest damage metals for fuel assemblies, and they still were asking for some of that data lately. We did medical isotopes. We proved that with this flux in this core, FFTF being a fast flux, a higher energy flux, you could make all kinds of materials. We could test fusion materials 10 times faster than any other place. So we could test for the next generation of reactors.
We pushed materials to extents that they had not been pushed to before. We developed fuel with higher burnups than had been developed in the US before.
The ability to monitor, and the way FFTF was instrumented, the ability to monitor everything that was going on in that core for fuels and materials development was the significant contribution, or one of the major significant contributions that FFTF has made. Most of the people from Westinghouse were from the Navy nuclear program, and so the management excellence that Rickover had basically created in the nuclear Navy, and the technical excellence was transferred out here.
In my mind, the two reasons for the excellent operating record of FFTF and the safety was twofold. Number one, in the design, number two, in the people.
A lot of the operations stemmed, and it hurts me to say this, from the Navy and the way they did business. Long before there was really conduct of operations, which really started to come into the picture in the 1987 time frame thereabouts. The discipline of operations was different. The way that we conducted business was a cut above the rest of the site just because it stemmed from a naval background.
So it was a very regimented, regulated, and prescriptive environment. And the combination of the over-designed systems and the tremendously safety-oriented quality of operations ConOps people together contributed to the success over the 10 years that we operated of FFTF.
Harv and I were in the same operations technician class, you know, the basic class starting out. And there was approximately 30 people in that class. And it was so competitive that they would carry out your grade point average to 4 and 5 decimal places to figure out who was in the lead. It wasn't me, but Harv was one of the top runners there.
They would post those grades after every test.
Oh yeah.
Like the scram switch, I could, and it was testable too, we could tell you everything that went, all the reactor trips that cause a reactor scram. You know, we had to list them out. Yeah.
Yes, the reactor operator, your job is to maintain 100% as close as you can. That's reasonable. So you would sit here and you go like that. And you could do this 3 times before you would move that control rod 1/10 of an inch. If I see a decrease, a sustained decrease on that, before we take that much of a temperature variation, my job would be to come over, hit the button, announce reactor scram, you know, and proceed on with the alarm response from that point.
So scram's a good thing because it protects the plant, protects the fuel, keeps everything in one piece. From a political standpoint though, anytime you scram, that's bad because our job was to keep this plant at power on mission. And so if you were scrammed, you were shut down. You were not doing your mission at that time. So that's, you know, the good and the bad for a scram.
So, you know, all the training that we went through to become reactor operators and chief operators and to run the reactor plant really was entailed to help us know how to walk that fine line between keeping the plant at full power safely, and when it wasn't, to recognize that early enough so that we could mitigate any damage to occur. When we first hired on, the whole thing was public safety. You know, OSHA came along later for worker safety. We used to laugh about we were expendable if the public was going to be safe by our sacrifice. You know, that's a joke, of course. But, you know, public safety was the big thing.
And then each operations crew had people who were qualified on these different pieces of equipment and in here, and you would move around and get, you know, so you wouldn't get stagnant on doing types of things. You could be the shutdown watch when the reactor shut down one day. The next day you could be out on the IVHM hut. The next day you could be doing plant refueling or just standing watch out in the plant.
Okay, this is the personal airlock. This is the entry point to containment. And we have 2 doors here, and this is so we could maintain the pressure in containment less than atmospheric. So there was never any leakage to the outside atmosphere. And that was so we could keep the atmospheric pressure in the containment at less than atmospheric, and so all the leakage, if there was ever any leakage, would be into containment device outside.
So it was lower pressure in here and then higher pressure, so it's pushing air into here.
That's correct.
Rather than blowing out.
Yep, you got it. And here we have containment. This has contained the primary sodium systems and our refueling machines. This is the closed loop X vessel machine, and this machine moved fuel assemblies from a storage vessel to the reactor vessel. Okay, here we have the equipment airlock. This is the passage we use to bring in all our heavy equipment on the railroad tracks here.
And again, the airlock, it just happens to be an airlock to handle a rail car, basically.
That's correct, yes. This like the personal airlock, one of these doors was closed at all times when we were at power. Okay, now we're going to go down to the top of the reactor vessel. It's called the head compartment. Okay, this is called the head compartment.
Okay.
This is right on top of the reactor vessel.
All right.
And we could access this space at 100% power.
Really?
Most nuclear plants you can't do that. Okay, this is the control console for the closed loop X vessel machine. This machine actually inserted the fuel assemblies into the reactor vessel, in-vessel storage location, and withdrew those used assemblies from that same location. And it also inserted 40-foot test assemblies from the center island portion of the core.
I think the most exciting thing was during refueling all the time, because there was a schedule. You're supposed to finish up in so many days. And if you hit that schedule in the morning, that would be the most exciting thing, I thought. Probably IM-Cell had a schedule over there the same way to process their assemblies there, but when you hit a schedule,
it was very hectic. I mean, especially like you said, during the refueling and shutdown, you had all these tests to perform during shutdown, on the way down, the refueling, the repair of equipment to get it back ready to continue the next cycle, startup testing, you're just going 100%. And then actually, once you got to 100% and finished your completed startup testing, it kind of got during the cycle run, then it got real calm and real quiet. I know that a lot of people who've left FFTF are doing well. They're managers elsewhere on site or in their other businesses. I think that they hired high quality people, and it paid. It's the expectation of doing the job right, doing it right the first time, and like I said, reinforce a conduct of operations, the way you do business.
You work with high quality people, and it seems like it just rubs off. You work up to their level.
The other legacy that FFTF I think left is that the quality of the people, and many of the people that were in the project office later on became into leadership positions. That history is there. It to the extent it can be preserved now, it can then be used in the future, so that the country will not have lost that tremendous investment in that research and those people.
Well, when FFTF was fully running, there was probably approximately 1,000 people, maybe 1,200.
There was, I don't want to say competition between the crews, but you know, which crew was better. Today, if you look, it's far more Crew B people have risen in the ranks of management than any other crew.
When I came to Crew B, it was working with Len Clossy, and each crew had its own personality. And Crew B was, I don't know, how would you describe Crew B, Len? It was a bunch of characters, I would say.
Yeah, that's probably true.
We had a little friendly rivalry with the other crews, and of course we think Crew A was the best of all 5 of the crews.
Well, Crew E was like F Troop. Everything would go wrong with them.
One of the other things I think that these guys will probably agree with is the operating crews were a really pretty tight-knit unit, and you really were a team running the facility, and it was amazing to see each crew operate. Like Al said, each one had different personalities, and each one could get the job done in the best way they knew how and do it their own way.
More than a job, it turned out to be a real family kind of a atmosphere, and then the people, that really what made this job. You know, we're sticking around.
The average age on those operating crews was probably around 26, 27 years old. Basically, I, as far as the career is concerned, grew up here. And I think a lot of other people did too.
We all still keep in touch. We all know each other's kids, and they're married. And
we're fortunate, and in a lot of ways it was family, because you got to know everybody.
It's an amazing place. It was an amazing design. It fulfilled everything we put it up to. It was an amazing group of people, amazing way of doing business. And there was a lot of pride in doing things well and with excellence.
The reputation I knew of from the development of our proposal on this contract was it had a very good operational reputation, a very good safety reputation, and so when we bid this thing, we were confident that we would come in here being able to use it, utilize and work with the existing workforce that was here, who already had this thing, had taken it from operations, now already taken it into a surveillance and maintenance mode, and to continue that legacy to complete the project.
What stands out to me about FFTF is the caliber of people here. The people that were still left had the experience to get that job done.
The way this plant was operated in the past, the way it looked when we came in, the pride and ownership of the people in this plant taking it further from operations to preparation for decommissioning. A lot of pride and ownership there that was obviously visible.
I found this to be an extremely clean plant. This is one of the cleanest plants I've ever been in. Contamination-wise, it's extremely clean. And this was a well-maintained, sweet operating little plant.
When I showed up here in 1980, after 7 years in the Navy, the plant was just so clean that it was almost a second thought that there might be any type of a spill or any type of radiation issues.
Our sodium system was pristine. We had very little damage or leakage from the system. You can go almost anywhere in this facility and find no contamination.
But the people here had the pride to keep the place clean, and a lot of people, even when we've been shut down in the last couple of years, when they come and look at the facility, they always remark on how clean, and it looks like you could start it up tomorrow. It's in such good shape. That's really a reflection on the workforce and the value system that was instilled in the operators here.
These people know the plant hands down, in and out. They can visualize in their minds where things were in cells that are closed out that you can't get to anymore. It just would not have been the same without a knowledgeable workforce. You know, if you would have hired a brand new guy off the streets that says, go shut down FFTF, we would have still been working on it. I think this workforce, you know, took the pride in operating the plant, and it also has the pride in shutting it down safely, and the knowledge they have has just been invaluable to shutting it down.
At FFTF, they had a good plan. I mean, they had it already on paper. They knew what the end state was going to be.
The plan was put together by the entire staff at FFTF. We worked as a team, looking at all the things that had to be done so we could take the facility down. At that time, we were working for Fluor Hanford as the contractor here on site. One of the things when they came in with the new contract, like I say, we wanted to make sure that they didn't take our plan and completely trash it, because like I say, there'd been a lot of thought going in on to put it together, and we were fortunate. When Bo came in,
we had a lot of faith in the plan as it was already, Wiley.
Yeah. Well, when Bo came out here, he actually came out a little earlier than all the transition stuff started, so he could get to know the people, know the facility, and so him coming in and really getting to know us, getting to know the plant, he challenged us on different things, and if we couldn't defend what we were doing, then that's a better improvement to the plant. And that's one of the nice things about being here at FFTF, is we weren't afraid to make changes when it was the right thing to do.
And everybody was open, straightforward, and conscientious. So you couldn't ask for a better group to come into as an outsider.
We've actually got a pretty good safety record here. No major injuries that occurred. We were able to maintain, a safety culture here.
I just walked through the gate out there. If you look at the board up there, you got over 1,500 days without a lost time accident. That's nearly 5 years. And you've got over 600 days without an OSHA recordable injury. So that same safety culture that was here, I would say, from operating a plant, has continued through with putting it into this minimum surveillance and maintenance mode.
Here on the Hanford site, you had transformers all over the place where they were watered down PCBs. Our transformers were pure PCBs. And so we had to go through, and we had 21, I think, transformers that we had to go through to drain them and then remove them so that they could be shipped off to be disposed of. We did it without any accidents, any spills or anything like that.
And I think one of the things we've learned in our past experience with decommissioning similar facilities is that as you change from that nuclear hazard in decommissioning, you see more you're dealing with the industrial hazards. So the electrical safety, some of these transformers that we were talking about were elevated on roofs, had to be loaded down from the roof down to the ground to be dealt with. So you have hoisting and rigging hazards, you have other industrial hazards with cutting apart equipment disconnecting piping.
Confined space?
Confined space entry, things like that, where you've got to go into confined spaces to disconnect things and isolate things. So you shift a little bit away from that nuclear hazard, and you're dealing with more some of those industrial hazards, and they've dealt with those industrial hazards very well also. One thing I would note that's very important to acknowledge related to this project with the efforts that were done by Fluor Hanford here was the fact that we have completed this activity ahead of the tri-party agreement milestones that are set for this facility. And that's an exceptional accomplishment to remove the fuel, remove the sodium safely, all done safely, and then continue through with taking it into a minimum surveillance and maintenance standpoint.
I first came to Hanford in 1957 when I left the Army as a GE Tech grad.
And I've been here 34 years. I started out after 8 years in the Navy, submarines. The rest is history. I've been here 34 years.
I started a project here in 1972, and I was a project engineer of the IBHM.
I started in 1974 as a senior engineer designing materials for nuclear reactors.
I've worked here at FFTF for 29 years. I'd spent 6 years as a Navy nuke, and when I got out, the nuke industry was going in a tizzy because 3 Mile Island happened at the same time. But this was a research facility. I really liked the mission that they had for FFTF and the fact that it was brand new, and decided to come out here.
After I got out of school, didn't have a job in central Pennsylvania, and got this job, I swore to myself, okay, I'll work for 3 years, pay off some bills, then I'm heading back east. I'm still here. So it's been 32 plus years that I've worked here at FFTF.
I thought maybe I'd be here a couple of years and then go do something else. And I've been here 29 plus years, and I'll be here till the end.
In '77, graduated from college, degree in nuclear engineering. When I first came in, the facility was still under construction. Bechtel was here. Westinghouse was present, slowly taking over. Some of the systems had been turned over to Westinghouse at the time.
What did you started in '79?
I can't start in '79, but it was, no, you were already through OT class.
Oh, okay.
You were on crew,
Oh,
and
okay.
I came on and got stuck doing all the grunt work.
Oh, blah.
I actually felt like I was the youngest person here at my advanced age, because everybody I met had been here 30 years or 35 years, and these people have been right here the whole time. They were fortunate.
And the other thing that was going on while we were putting all this fuel into the reactor, since it was the first time, what we were doing is doing all this physics testing. So you had a whole corps of physics people out here, and then, you know, when we got close to becoming initial critical, you would be every assembly. They would stop and run the test, and then you'd put another assembly in, and, you know, they had predicted where we would go critical, and they were right on the money with it.
But some of the neatest stuff I thought was when we were doing the inherent safe reactor testing.
One of the last experiments that we performed at FFTF was proving natural circulation.
This was the first reactor in the world to do a natural circulation test. That is where you take your cooling down to zero and the reactor is cooled by natural circulation. That was huge for an operating nuclear reactor.
The FFTF and the reactor systems after 3 Mile Island and Chernobyl, they wanted to prove they were safe. And they had a set of safety tests that they did with our whole reactor facility to verify the inherent safety features of FFTF and its fuel.
So it would never have had an accident like 3 Mile Island.
If you lost reactor flow, it would just shut itself down. It required no human reaction at all. So that's what they call it, inherently safe reactor.
In the current design, the Westinghouse AP1000 reactor, the latest generation reactor, is a natural circulation reactor. The NuScale Power, which is designed out of Corvallis, Oregon, is a natural circulation modular reactor. That is the passive safety reactors of the future, and FFTF was the first test to do that.
Additionally, there was a lot of early work done with the use of FFTF to produce medical isotopes. And there, in a fast reactor, you can produce isotopes that you can't produce in a thermal reactor that have application for treatment of cancer. So that is another kind of long-term potential for the experimentation that was done at FFTF.
We also had a whole test for medical isotopes. We demonstrated the feasibility of generating many medical isotopes.
We made a lot of gadolinium-153. I remember we made so much once that the price went down in the market because we made so much, and that's used for osteoporosis detection. We thought that was a very worthwhile effort to do that.
And so that legacy of being able to produce medical isotopes in the fast flux reactor is part of our history. But the coup de grace, the one test that is really having a major impact in it right now, is that we took a small amount of technetium-99, iodine-129, demonstrated we could change those to non-radioactive materials.
The long-lived isotopes that create so much difficulty for disposal can, in a fast reactor, actually be irradiated, and those isotopes can be transmuted into shorter-lived isotopes, and ultimately you reduce the amount of real waste that comes from the use of nuclear energy from the atom to a very small amount, and then that waste can be vitrified, but the quantity of waste is very small.
And people say, how could you possibly take a radioactive material, put it in a reactor and make it non-radioactive? But with our scientists, we're able to slow those fast neutrons down just a little bit to capture these and destroy these materials.
There's not a lot of reactor operations people that get to see something from cradle to grave. And for most of us in this room, we were here during sodium fill, initial critical operations, and now we've put it to bed. And so we've seen the full life cycle of a reactor, and that's a very interesting aspect to see.
We operated safely for 10 years. We added to the technological database. We contributed to advanced fuels, and we operated for 10 years with no significant injuries, events, or environmental insult.
Yeah, after spending so many years here with this and, basically going through initial fuel load, and start up, and then, taking it through its 10 years of operation, and then, hauling all the fuel out of here and draining the sodium. For 30 years, that's a long time, to be part of your life. A lot of good people that came and went through here. I'll miss it, oh absolutely, but am I going to lose sleep over it? No, our job changed, to go ahead and take this down. And, that's part of the thing that was nice about this, is that we were able to maintain that same quality, that same conduct of ops here to bring it down. And so they did a good job. We did a good job.
This place was filled with excellence, how we did business and how we maintained the machine. And what we pride ourselves on is doing whatever the mission is with excellence. So we started it up and we filled it with sodium and we ran it with excellence. We kept it in hot standby while they decided what to do with excellence, and we want to put it away with excellence. And so the people who are still here are still here. It's more than just a paycheck. It's a matter of pride.
Coming to the site at CH2M HILL to operate and decommission the central plateau. I'd like to thank the workforce that had been here throughout the years ever since the plant started up, operated, and now taken it into minimum surveillance and maintenance mode, and thank them for their efforts and the commitment they've had to this project and seeing it through to the end. And so I think that's greatly appreciated for the commitment to that and completing the project.